Okay, students, welcome you all again. So, in our sessions, we were solving the problems of permutations and combinations. In the previous class, we have nearly solved some 15 problems. Okay, so here today I am going to continue the same problems from where we have left in the previous class. And you may know that we have completed nearly 14 problems. Okay, the 13th problem is already over, and 14th problem is also already over. Okay, now we have to go for the 15th problem. Clear? Okay, so here we can go for the 15th problem and we shall see what they are asking in the 15th problem. In the 15th problem, they have given that there are 8 floors on a building, including the ground floor. If 4 persons enter the lift in the ground floor, the number of ways in which they can get down the lift if no 2 persons come out of the lift at the same floor is. Okay, so that means you just see here there are 8 floors. Okay, let us take this is ground floor, this is F1, this is G, and this is F2, and this is F3, F4, F5, F6 and F7. Okay, including ground floor there are 8 floors. Including ground floor there are 8 floors, and 4 persons enter into the lift. So there are 4 persons inside this lift. Now what is the condition? This lift moves on, and now we have to find the number of the ways in which the persons gets out of the lift such that you just see no two persons come out of the lift at the same floor. Okay, at the same floor the 2 persons must not come outside. Clear? So that means you can just see here, if 2 persons simultaneously not comes outside means the number of cases will be like this. 4 persons come out of the lift in 7 floors will be 7p4. Okay, 4 persons come out of the lift in the 7 floors, that is except the ground floor, because in the ground floor all the 4 persons will enter the lift, so there is no chance to come outside. So now you have left with 7 floors. Okay, and you have 4 persons, and 7p4 will be the number of the ways in which the persons can come outside the lift. Clear? So that will be 7p4. 7p4 will be the right answer. Clear? Very simple question, but you have to understand the question carefully and then you have to solve. How much you understand the question, that much it is good to answer this type of particular questions. Okay, now quickly we can move to the 16th problem. Okay, so this is a straightforward formula, that is the number of permutations of n dissimilar things taken r at a time. The number of permutations of n dissimilar things taken r at a time in which particular things always occur is. So this is Directly straightforward formula, you can just see the particular things can be arranged in any one of the r places in r ways. So remaining r minus 1 places can be arranged with n minus 1 things. So therefore n minus 1 p r minus 1 ways. So therefore n minus 1 p r minus 1 ways will be the right answer. Therefore the remaining r ways have to be multiplied here. So the total number of the ways will be r multiplied with n minus 1 p r minus 1. Okay. So because here you can just see the particular things can be arranged in any one of the r places. So that will be r ways. Okay. And the remaining r minus 1 places can be arranged with n minus 1 things. Okay. So that will be n minus 1 p r minus 1. Because you just see n dissimilar things taken r at a time. That means you got n different things. See, let us take these are the some n different things. Okay. So from this n different things, we have to choose r elements at a time. And these r elements always occur. These r elements always occur. Okay. In which particular things always occur. This means these three objects has to always occur. So these three objects can be what? These three objects can be arranged in three ways. Clear? So this 3 is multiplied with the remaining things, that is what? Total n minus 3 p here r minus 3. Okay. So therefore now this will be the answer for this example. So on the same way, r dot, r value is here 3. So r dot n minus 1 p r minus 1 will be the right answer. Okay. So for that you can just see option 2 is the correct one in this particular question. Clear? So I feel everyone can understand this, and you can also go through this problem. If you have any doubts, you can clarify them by watching the video again and again. So if you get some more doubts, you can comment in the comment box so that I can clear them. Now let us go for the 17th one. Number of permutations that can be formed with the letters of the word triangle. Number of permutations that can be formed with the letters of the word in the triangle. Okay. So you just see the number of permutations you have to calculate from the word triangle. Here in this type of problems, you have to find out if any terms are repeating or not. T is repeating or not? No. R is repeating or not? No. I is repeating or not? No. A is also not repeating. N is also not repeating. G is also not repeating. L is also not repeating. E is also not repeating. Okay. So now from the straightforward with the formula of, see, triangle contains 8 distinct letters. 8 distinct letters. That means no, the letters are repeating here. So it is very easy that it can be arranged in 8 factorial ways. So therefore, if the numbers are repeating, you just see n factorial divided by the factorials of repeating letters. Okay. So this will be your answer. Okay. So very simple problem. So that's why no doubts, I think. Okay. So option 1 will be the right answer. Now we can move for problem number 18. In the above problem, the number of words which begin with T is. Okay. So now what they are asking? They are asking only the number of words which can begin with the T. That means you see students, here you have 8 places. 1, 2, 3, 4, 5, 6, 7 and 8. So here T is fixed. Here T is fixed. Now you got how many? 7 places. 1, 2, 3, 4, 5, 6, 7. Okay. So this will be the hint for you. Because T is fixed, it has not got any choice. So now with this you can understand it has got t is fixed in the first place. Now you can just see this t is fixed in the first place, and the remaining 7 boxes or the 7 places, this remaining 7 places can be arranged in 7 factorial ways. So therefore the answer will be 7 factorial. The answer will be 7 factorial. Clear? So in this type of problems, as I say, you have to be very good at concept. If you once good at concept, then really you are going to enjoy the concepts. Okay. Now let us go for problem number 19. The number of 4-digit number that can be formed with 0, 1, 2, 3, 4, 5. Okay. The number of 4-digit number that can be formed with 0, 1, 2, 3, 4, 5 is, okay. So there are 4 options, no problem. So see here, the number of 4-digit number that can be formed with, that means you have to form the 4-digit number. You have to form the 4-digit number. You have the choice of 0, 1, 2, 3, 4, 5, 6. You have 6 choices. You have 4 places. And you can just see here the number of 4-digit number that can be formed with these numbers means 0 can't come here. 0 cannot come here. That means this place has got only 6 choice. The other things has got 7 choice. The other things has got 7 choice. Okay. So 0 cannot come in the first place. The remaining things no problem, because 7 can come. All the 7 other 3 places have 7 choices. Okay. So like this also you can find. Otherwise you just see here the total number of the digits will be how much? The total number of the digits will be 6p4. Okay. In that we have to subtract the starting number with 0. That means 3-digit number 6p3 we have to delete. Okay. So if we do this, we will get the right answer, because this is 4-digit number, this is 3-digit number. So as I said, 0 cannot come in the first place, that we have to remove. So therefore 6p4 minus 6p3 will be the right answer, because 6p4 gives us all the 4-digit numbers where 0 is at the first place. So from that I should delete the 3-digit number. So therefore 6p4 minus 6p3 will give you the right answer, that is option 4. Okay. So like this you have to solve the problems, so that you can also enjoy the things and you can also understand the concept. Now quickly we can move for the next problem, that is 20. The number of permutations of 4-letter words obtained from the letters of the word article is. The number of permutations of the 4-letter words obtained from the letters of the word article. See, the article word is given. So from that what they are asking, the number of permutations of 4-letter. The number of permutations of 4-letter words obtained from the letters of the word article. So from this you have to create 4-letter words. Here see 1, 2, 3, 4, 5, 6, 7. So 7p4. Okay. 7 letters. From that you have to select 4. So that 7p4 will be the right answer. Clear? So therefore 7p4 is going to be the right answer. Now let us go for 21. In the above problem, the word of the number in the above problem, the number of words which contain a is. That means a has to be there in the word. Okay, that means one letter a, that is fixed wherever it may be. Okay, so total you have a can be arranged in any one of the places, any one of the 4 places, so that it has got 4 ways, and the remaining letters has got 3 places. So therefore you can just see here 4 letter word you have to make. Total in the letter you have 6. 1, 2, 3, 4, 5, 6, 7. Okay, you got 7 letters. In that, A has to be arranged here in 4 ways, and the remaining A is gone means 7 are remaining. Out of 7 you have to select 3. So 7p3. Sorry, total there are 7 letters. 1 is gone, so 6 you have to take. 6p3. So 6p3 multiplied with 4. Okay. So this will be your answer. That is, total number of the ways is 6p3 into 4. So all of you know that 6 factorial divided by 6 minus 3 factorial into 4. So that will be 4 into 5 into 6 into 4. Okay. So you can simplify this. You will get 480. Clear? So now 480 is going to be the right answer for this particular problem. Okay. So for the 21st problem, you can just see 480 is going to be the right answer. Okay. So very nice. The problems are very simple, but you must know the concept. That's all. Okay, the number of 5-digit numbers that can be formed with 0, 1, 2, 3, 5, so that no digit being repeated in way number is. Okay, 0, 1, 2, 3, 5, so that no digit being repeated in any way. Okay, so now you see you got 1, 2, 3, 4, 5 numbers, and the number of 5-digit numbers that can be formed with these 5 numbers, so that no digit being repeated. So that's why you can also see that you have got 5-digit numbers, 5 digits, that is 0, 1, 2, 3, 5. So by using this, you can just see no digit is being repeated means 1, 2, 3, 4, 5. You have to make 5-digit number. 0 I can't use here, so that it has got only 4 choice. It has got 4 choice because no digit is repeated, because already 1 is used. So it has got 3 choice. It has got 2 choice. It has got 1 choice. Okay. Because you see here there are 5 digits. Out of this 5 I can use only 4 here. Okay, one digit is already used out of 5. So 4 are remaining. So here out of that 4, 3, 2, 1. Okay. So 4 into 4 into 3 into 2 into 1. 16 into 3, 32. 32 into 2, you can just see 16 into 3. 3 into 6 is 18. 3 into 1, 48. 48 into 2 is 96. So therefore 96 is going to be the right answer for problem number 22. Okay. Now let us go for 23rd one. The letters of the word random are arranged in all possible ways. The number of arrangements in which there are 2 letters between R and D. See here, the letters of the word random. The letters of the word random are arranged in all possible ways. The number of arrangements in which there are 2 letters. Between R and D. There are 2 letters between R and D. Okay. So these are the 4 options, and you can just see here what they are telling. Random are arranged in all possible ways. The number of arrangements in which there are two letters between R and D. See here, there are two letters in between R and D. Okay. So now here R is fixed, here D is fixed. Anyways, this can be arranged in two ways. This can be arranged in two ways. The remaining letter, there are four. Okay. So they can be arranged in any number of ways. See here, R and D is used. So 1, 2, 3, 4. 4 letters are there. Okay. So now this 4 has got these 4 choices. So for that you can just see there are two letters between R and D in 3 possible ways. And next you can go for this 144 is your answer. Why? Because you just see here this has got 4 choice. Here also they have got 4 choice. Here also they have got 4 choice. That means here you can just see you can add this case 1 plus case 2 plus case 3. Okay. So here you can just see R and D are fixed. So these 4 places and you got 1, 2, 3, 4. That means 4P4 plus 4P4 plus 4P4 will give you the right answer. Okay. So therefore 144 is going to be the right answer. 144 is going to be the right answer. Clear? Okay. So that is what we are explaining here. R and D can be arranged in 2 factorial ways in all 3 cases. Taking 4 blanks filled with 4 letters, 4 blanked with 4 letters, that is 4 factorial. So 4 factorial means you have got 3 cases. So all 3 cases has to be multiplied. So therefore 3 into 4 factorial and 2 factorial is the arrangement of R and D. So that gives you totally 144. That gives you totally 144. Okay. So 2 factorial 3 times of 4 factorial. That is 4P4. Okay. So now 4P4 is nothing but 4 factorial. So 4 factorial is 24 into 3, that is 72. 72 into 2 will be 144. So 144 will be the right answer. Okay. So answer key 3 is the correct answer. Now we can go for problem number 24. The number of ways one can arrange the word with the letters of the word Madurai so that always vowels occupy the beginning, middle and the end places is. See, the number of the ways one can arrange the word with the letters of the arrange the words with the letters of the word Madurai so that always vowels occupy beginning, middle and the end places. That you can see arrangement here. Vowels can be arranged in 3 places, beginning, middle and the end, because Madurai contains 3 vowels and 4 consonants. So Madurai contains 3 vowels, 4 consonants. So 3 vowels can be arranged in 3 factorial ways and the remaining 4 consonants can be arranged in 4 factorial ways. So therefore 3 factorial into 4 factorial will be the right answer, because here you can see A, I, U are the vowels, A, I, U are the vowels and the remaining consonants are M, D, H and R. So 3 vowels and 4 consonants, this can be arranged in 3 factorial ways, this can be arranged in 4 factorial ways. So therefore 3 factorial into 4 factorial will be the correct answer. Okay. So therefore 3 factorial into 4 factorial will be the right answer. That is answer key 4 will be the correct one. Now we can go for the 25th problem. That is the number of permutations that can be made, from the letters of the word Sunday, without beginning with S and without ending with Y. Without beginning with S and without ending with Y. The number of permutations that can be made from the letters of the word Sunday without beginning S and without ending Y. Okay. So therefore you can just see the number of words can be formed are 6 factorial, because here how many what letters you have? 1, 2, 3, 4, 5, 6 letters you have. So that can be arranged in 6 factorial ways. The number of ways that starting with S are 5 factorial, because S is fixed here. The other 5 places can be arranged in 5 factorial ways. Okay. And ending with Y, the number of letters ending with Y, you can just see they are also of 5 factorial. So the number of the words starting with S and ending with Y are 5 factorial. Okay. So now the total number of the arrangements will be what? 6 factorial minus 2 times of 5 factorial plus 4 factorial. Okay. Because in 6 factorial the total number of the arrangements will be there, minus 2 times of 5 factorial. So in this there will be S in the starting place. Okay, 1, 2, 3, 4, 5. Okay. And in the another place Y will be there, so that has to be deleted, and plus 4 factorial, that is where S and Y are in the first place and the last place. So therefore by using this we get 504, that means 504 number of the ways of the arrangements, of the total number of arrangements. Clear? So 504 is the right answer. Okay.